Hello everyone, my name is Wang Ringcha. Today, I want to introduce my post evaluation criterion for visual cryptography schemes via neural network to you. First, what is visual cryptography? Visual cryptography is to distribute a secret image to different shells so that the original secret information cannot be recovered without the cooperation of several shells. Moreover, each shell is kept secret to the other. Next, I'd like to introduce why the visual cryptography scheme needs to be evaluated. It is difficult to evaluate the security and performance of visual cryptography scheme for grayscale and color image. Firstly, when some visual cryptography scheme are used to divide image into shares, there is no guarantee that each share would not reveal information about the original images. Secondly, it is hard to determine if one can always derive the same information from the original and the recovered image. If the recovered image cannot convey the key information as the original information, then the encryption will be meaningless. Then, let's talk about visual cryptography scheme. Firstly, host scheme. This figure is the workflow of host cryptography scheme for color image. This scheme uses color decomposition to derive the color image into three primary colors: yellow, magenta, and cyan. Then use the technique of half-truth technology to get three different shares. Then token these shares to recover the image. Comparing to host scheme, Nakajima and Yamaguchi scheme is different. Besides original image, this scheme takes two other images as a container for hiding secret shares, and an encrypted image is generated by combining the containers and a piece of information from the original image. Then the decryption is done by stacking these shells together. Then I'll talk about our method. First, I'll introduce encryption inconsistency. Through the neural network, we can get the level of original image R. Use label R to denote this. Meanwhile, we can get the level of shells denoted as the level S. By comparing level S with level R, the inconsistency can be obtained. You can see this formulation. Then it's about decryption consistency. Through the neural network, we can get the level of recovered image, denoted as level M. By comparing level M with the level R, the decryption consistency between the recovered and original image can be defined as the follows. After introducing two criteria, I'll talk about how to adopt inconsistency and consistency for host scheme. We randomly select 20 images from the ImageNet dataset and perform the host scheme on these 20 images. We obtained three shares and one recovered images corresponding to each original image. Then, via neural network, we get the levels of all shares and recovered images and the original image. By comparing the obtained levels, one can easily derive the inconsistency. Furthermore, the consistency can be obtained. This figure shows how to calculate the inconsistency of the host scheme. Then I'll talk about how to adopt consistency for Nakajima and Yamaguchi's scheme, since two containers are used to encrypt the original image as shares. The shares will barely reveal the information in the original image. Our evaluation of this scheme mainly focused on this consistency between the recovered images and the original images. We randomly select 20 images from the image dataset. The 20 recovered image that correspond one-to-one with the original images are obtained through this scheme. The level of this are obtained via neural network, and the consistency are obtained from this formulation. This figure show how to calculate the consistency. This table presents the inconsistency and the consistency in host scheme. From the experimental results, we observe that with the identification of three different CNN, VGG16, VGG19, ResNet15, the inconsistency of the shares and the original image is as high as 100%, which means that shares can conceal the images information of the original image very well. However, the consistency of recovered image and the original image is zero, which also means that recovered image is quite different from the original. Then, this table presents the consistency in Nakajima and Yamaguchi scheme. We find that the consistency of recovered image and the green image of original image is zero, which also means this scheme does not perfectly recover the original image neither.